what I'm going to do today is I'm going to cover up on chapter 6. I'm going to do a little bit of that, and then we'll hit up on chapter 7, or not chapter, but function 6 and function 7. A lot of you folks asked me for help for the function 6, and I almost feel like first of all, it's kind of a complicated equation. Second of all, maybe I might have put in my answers wrong. So I'll double check that, but I'm pretty sure I did it correct. Maybe, I don't know. Why don't we take a look at it today? I'm going to spend class time in class doing that. So if you can remind me from function 6, I think it was y is equal to negative 16t squared. Help me out here, folks. What was the rest of it? Plus 50 or something? Plus v naught, oh yeah, okay. Plus v naught t. That's all I gave you, right? Plus v naught t, okay. And this is the general equation from physics, basically, but we also know this as a quadratic equation. If I want to know what, I'm going to go through this part real quickly. If I want to know what time is ball on ground, or I guess person. What time is person on ground? Charlie, you need to sit over here because I don't have any room. All right. What time is the person on the ground? Well, then what we do is we set, no, not t equal to 0. We want to know the time, so we set y equal to 0. Because that's what it's defined as person on ground, is height is equal to 0. So actually, maybe this was an h instead of a y. Is that what it was? I don't remember. Anyway, yes, h equals 0. H is equal to 0. So you set this sucker equal to 0, and you get 0 equals negative 16t squared plus v naught t. And then I basically solve for that, and so I put 16t squared on the other side equals v naught t, divide both sides by t, and then I end up getting the time that I'm looking for is v naught over 16. Because I'm asking what time this is going to happen. So, everyone cool with that? So that's the time at which the thing is on the ground. So here's my question: is if he is on the ground at time equal to 0, or time is equal to this, then what time is the highest point? All right, Courtney, you say kind of. What part scares you? Do you not know where I got the 16 v naught 16 over, or v naught over 16? Is that what's freaked you out? What's your thoughts? Oh, what is v naught? This is initial velocity. This is the speed at which the person leaves the ground. And we, excuse me, we don't know that yet, but that's why we're putting in it as a variable. We don't know what it is. Is that what freaked you out, Courtney, what the v naught was? Okay. Sometimes what I do is I have a VI and a VF. And this stands for initial velocity versus final velocity versus VM or V1 and V2 and all of that kind of stuff. That's just talking about for the different velocities. What I usually do is when I put a little 0 on the bottom, that means the initial velocity. It's also the same as VI. I don't like writing VI because we reserve that in math for something else, so I put a little 0 and I call it a naught for some reason. I have no idea why it's called naught. That's just the way it was since I was a little kid. That's the way they did it. That's what V naught is. And I solved it fast. Yes, I did solve it fast because this isn't the heart of the problem. This is just the first couple of steps. If this is the time at which the person is on the ground, at what time is the highest point? Well, that would be, I don't know how we want to designate this. Maybe we'll call it T 1/2, sub 1/2, which means v naught over 32. Because if this is the time at which the person is on the ground again, then this would be the time when they're the highest in the air. It's halfway in between. Does that make sense? So halfway in between just means I multiply this first time by 1/2, which makes that bottom part of 32. Are we cool with that?
Did they say yes?
Well, actually, Jenna, you're asking, will this equation help us find how long they are in the air for? Well, actually, this is how long they are in the air for. We already found that. That was the first one. They were in the air. They were on the ground exactly at time equals 0 and time equals whatever v naught over 16 is. You want numbers. I know that you want numbers, but I can't give you numbers yet because I don't know the velocity of the person. You see what I mean? In homework 16, what information did I give you? I think I only gave you how tall they were and how high they reached. Yeah, but I didn't tell you how long they were in the air for. I didn't take out a stopwatch and measure that. You see what I mean? So I wish I could give you numbers, but I can't because I don't know the time. I don't know the velocity initial. So we're dealing with stuff we don't know just yet, but we'll bring it back to the information we want. Now, look at this. My original equation, I'm going to call it h as a function of t is equal to negative 16 t squared plus v naught times t. That's the original equation, nothing to freak out about. The only thing I added was this t, and that's not h times t, that's h as a function of t. Does that make sense to you? Yes, exactly. It's h of t. It means my variable is t. That's what I'm getting at here. Okay, I'm going to make a new one called hm, where I basically said if I want to find, this is the time, this right here is the time at which the person is at their greatest height. So what if I wanted to figure out what that greatest height was? So what I would do is I would take that time, because this equation over here says, here's my height for any time that you want. And I say, wait a second, sir, I'm very interested in a very specific height. The height that I'm interested in is h, maybe I should write it like this, h evaluated at t 1/2. Evaluated at that specific time because that will give me my maximum height. Hey, Keisha, come on in.
Hi.
Sorry, Shiloh, can you go over here? Keisha, can you take a chair and put it right here?
Thank
All
you
right.
for speaking.
All right. What is time 1/2? Well, it's this, what I circled it. I don't know what the number is just yet, but I mean, that's what it is. Are we cool with that? It's the time at which the person has reached their highest part of their jump. Shiloh, if you want, you can come over here and draw on the board. Okay, I'm sorry, I don't have any room over here, okay?
Okay.
So you're just going to have to do your best, okay, cool? All right.
Thank you.
So what I'm going to do is I'm going to plug in, I'm going to rewrite this equation, but I'm going to plug in the v naught over 32 for wherever I see the time, the t 1/2. So this would be negative 16 times v naught over 32 squared plus v naught times v naught over 32. Because this is my h, I'm evaluating my h at a very specific time, at the time when the time is equal to v naught over 32. Does that make sense? And why do you think I put an h with a small little baby m on the bottom of it? It's the maximum, exactly. It's reminding me that this height that I'm looking at is max. No, it's not a function of m. If it were a function of m, then I would put it in parentheses. But I put a small little m in there because it's telling me, hey, I'm talking about a very specific height. Technically, I could write it like this. My height is no longer a function of time, it's a function of v naught. Do you see that? It's a function of the velocity.
That makes sense.
Is equal to negative 16 v naught squared over 32 squared plus v naught squared over 32. So if I wanted to write it with the as a function of part, I could put a parentheses v naught, but that small little m stands for maxima. It's reminding me that I have a bunch of heights that I'm looking at, but this height that I'm talking about is the maximum height. It's the height that you would be if you evaluated exactly at halfway in between the jump. Does that make sense to you?
Yeah.
Okay. So we know what this is. We can figure that out from the table they gave us in the problem. The question is, what is this? Well, we could solve it. Negative 16 over 32 squared. That would be I'm going to play some funky math here. Not funky math, but I don't have a calculator, as I never do. So, is everyone all right if I just do this kind of like a little bit of a trickiness here? All right. I'm going to write this first 32. Actually, you know what? I'm going to write both 32s as 16 times 2. Okay? So this would be negative 16 times v naught squared divided by 16 times 2 squared plus v naught squared over 16 times 2. I'm just doing this just because I don't really... No, I'm not going to use Jenna's answer. I don't have a calculator. It will be quick. This is negative 16 over 16 squared times 4 plus v naught squared over 16 times 2. So this would be, this cancels out with that. So I had negative 1/4 times v naught squared over 16 plus 1/2 v naught squared over 16. That leaves me as 1/4 v naught squared over 16. Did I do that right? Okay. And actually, Jenna, this kind of makes me think that I did something wrong with you. This is my h. HM to be exact. Yeah, I think that when I calculated with you, I put a 1/2 over here. And now that I'm looking at it, it looks like it's a 1/4. Anyway, what I'm going to do is I'm going to multiply both sides. I'm going to clear out the fractions. Anyone know what 4 times 16 is? That's what, 64?
Yeah. Because it'd be... Well, I don't know, actually.
Okay. And so now I can calculate out what V naught is. V naught is equal to the square root of 64 times HM, which is really just 8 times the square root of HM. is equal to V naught. Actually, to be honest with you, I think that maybe I messed that up on my calculations. When I put in your answers. So this is the velocity initial of the person jumping. Yeah. So let me pull up chapter 6 homework so you guys can get a reference as to what the heck we're talking about. Okay, so you can get a reference to what it is that we're talking about. All right. Okay, all right. So what we're doing is we're figuring out the jump height in inches, and then we figure out the jump height in feet, okay? And then our initial velocity is we take this jump height, take the square root of it, and multiply it by 8, and that will give you your initial velocity. And I'll tell you what, let me go through and double check all of these answers to make sure it's correct. I made a little spreadsheet for myself to help me out with it. All right, let's try it. Let's do this. All right, let's see. 12 feet, 4 inches. Actually, you know what? Let me look up my Google Drive.
Is this Jenna, the Jenna that lives on the Big Island?
Yep, this is Jenna, Big Island Jenna. Did you meet her?
Yeah. Hi, Jenna. It's Acacia. We were in the writing workshop together.
Oh, yeah?
Yeah.
See, that's the cool thing about these things, about meeting up with the students. You finally get a face to put to the
Yeah,
person.
she's fun.
Yeah, she's cool. Let's see. Is this Untitled Worksheet? Oh, here we go. All right, so here's what I did. This is the way I did. Oh, is that all there is?
Shaquille O'Neal, Kobe Bryant.
You didn't do much. Oh, seriously, that's all there was. Huh. Oops. Okay. Maybe I did it in a different spreadsheet. Let me go over to my other account.
That's what happens to me. Sometimes it opens my stuff on a different account and I don't notice. And I just do all the work there and then I wonder why I can't find it.
Sorry.
Oh.
There you go. Func 6 homework. Obviously, this is the one. Okay. So Shaquille is 9 feet 8 inches. That gives him a total of 116 inches. And I just had this thing multiply the feet by 12 and add the inches. Good. And then his touch was 12 feet 4 inches, giving him 148 inches. His jump is 32 inches because you just take that cell minus the original cell, and that's how tall it is. You divide that number by 12 and you get 2.66. And his initial velocity was the square root of this times 64. Hey, that's what I said, right? It was the square root of 64 times the height.
Oh, yeah.
Oh, okay. So his
Got it
initial
there.
velocity was 13.0639, and his time in the air was actually calculated back here where I circled it. It was just your velocity.
Oh, I have to leave.
Oh, no, it's not what I circled. It's this one where I boxed up here. It's your velocity divided by 16. So you just take that velocity and then you divide that by 16. There you go. So, by the way, these are all the answers apparently. Now you guys are like, oh, let me copy that down. Let me just make sure that I put this answers incorrectly into the quiz.
I have
Oh.
the graduation meeting.
Okay, some of you guys have graduation meeting, but what is it that we're doing? Some of you guys asked for function 6 homework, so I'm showing you how to do it actually. Because a lot of you were having trouble with it. It was not that easy. Oh, see, look. That's the right answer. Right there, 13.0639. That's what I said. And if you put in 13.07, it should give you that correct because the margin was 0.001. So the margin should be acceptable because, I mean, it would give you a correct answer for 13.0739 if you put in that or somewhere within that.
Isn't that not the same thing, though? Because if you were to round that 6, it would be 13.7.
Oh, Jenna was screwed up the formula. All right, hey. You screw up the formula, that's on you, my friend. Yeah. Anyway, that's how I did it. So, if you guys want all the answers, go back into the archive and look. Oh, I gave you the wrong formula. Oh, well, that's back on me. You're right. But keep in mind that I was doing it on a scratch paper while I was cleaning up. Off the top of my head. So hey. Well, no, I'll still totally take responsibility. I'll take responsibility. I screwed that one up. I apologize. When I was helping out Jenna, I gave her the wrong formula. But now I gave everyone the correct formula because that's how the formula I used to put in the answers. Can we move on to chapter 7?
Mm-hmm. Can I? I gotta leave, but can I watch the rest? I'll watch.
Yeah, you can watch the rest. All right.
Okay.
Cool.
Sorry to squeeze in.
Don't worry about it. I'm going to miss chem class because I have dentist. All right, cool. Well, not that cool. Can we talk about Func 7? I'll tell you what, Ethan. Why don't we do this? I'm going to open it up to you. Let's talk about Func 7. I want to move on to Func 7.3, but were you confused about something in 7.2 or 7.1? They were actually really easy, I think. Okay, I'll show you how easy this stuff is. All right, why don't we do a Func 7 recap, and hopefully you watch the videos because the videos are actually pretty straightforward and cool. But I will do a Func 7 recap. It will be quick, so if there's something that you feel like, wow, Mr. Dalton, you went way too fast on that, then wait. Or not wait for me, but go watch the videos, and that probably will fill in a lot of the gaps that I might be making right now. Okay? All right. This right here, let's see. Where should I start? I think I'll start right here. Okay. This right here. Yeah. This right here is a cubic function. Okay? It's the graph of any general cubic function. In fact, actually, it's the graph of this specific cubic function. F of x is equal to 1/4 x cubed minus 1/2 x squared minus 2⁴ x plus 4.5. You don't need to write that down. I'm just letting you know that that's what the graph is, and it looks kind of like this. If you were to put that in Desmos, if you were to put this in Desmos, you would basically see this graph. Cool. Now, how can we use this information to, find some answers? For example, when we were doing parabolas, we were all about finding the zeros. We did many things to find that. We factored, we used the quadratic equation, all of that kind of stuff. So, is there a quadratic equation for a cubic function? The answer is no, not really. There's no real simple way to figure out the zeros of a cubic or a fourth or anything higher than a square function. So our quadratic formula, I hate to say, is one of the best ones we can do. Anything after that, it becomes too hard. And it's not really even math that I don't necessarily lack the math skills to be able to teach it to you. I think that math lacks the math skills to be able to teach you how to find something higher than a cubic function. I think there's a math proof that anything higher than a fourth power function is impossible to, not impossible, but doesn't always come out nicely for you to be able to have a formula for it. So how do I even graph that? Well, there's a few techniques. One way is to have a computer do it, and the computer literally just makes a big table, x and y coordinates, and plots each dot in there until they get a graph. They put those dots really small and they make them close together so it looks like there's a line when there's not really a line in between them. But using the computer, we can actually get good pieces of information. For example, if I asked you, what x values give you f of x equal to 0? Well, f of x, this is the y. So what we're asking is, when does y equal to 0? Now this vertical axis, that's the y-axis. So I'm asking, when does the graph cross the x-axis? Do you understand what that is? Yeah, so when does it cross the x-axis? And we know that it crosses 3 times. By the way, I've just kind of been slightly feeding you this information, but I mean, some observations that we made is cubic functions, they have 3, or they could have up to 3 x-intercepts. They could have 1 x-intercept, they can even have 2, but at most they can have 3. We also learned that cubic functions have 2 times that they turn. Got it? So I call them bumps. They're not actually bumps. I guess you can call them turning points is actually the correct word for them. But they have 2 times that they turn. If something is to the 4th power, it has 3 times that it turns. If something is to the 5th power, it has 4 times that it turns, and so on and so forth. And we kind of came up with this idea that whatever the power is, it can turn 1 less than the power amount of times. Yeah. I just assumed that for each number along the x-axis increases by 1. Yeah, okay. All right, you can do that. Also, it can cross 3 times over here. So what I'm looking for is, when does y equal to 0? And what you can do, in fact, what I'm asking you to do in 7.1, 7.2 is simply look at the graph and tell me what your answer is. So if we open this graph all the way and then we zoom in maybe a little bit. Zoom in right here and a little down. There we go. We try to look at that graph perfectly. All right. At what points does y equal to 0? Tell me the 3 x answers that y equals 0. 4.5. I disagree. Lucas got it. -3, +2, and +3. There we go. In fact, that would almost imply, kind of going off of what our quadratic quest that we've done. Let's see, you said negative at x equals to -2, or I'm sorry, -3, +2, and +3. Is that correct? Kind of going off of what our x, or our parabolas trick that we used, would you venture to say that I could almost write down this as y is equal to x plus 3, x minus 2, and x minus 3? Would you venture to say that? Yeah, I think so. Okay. I agree with you. Yes, absolutely. In fact, maybe I'll put an A out in front here, not a 9. An A out in front. Okay. And that's kind of like will change the stretchiness of my graph. You know what I mean? Actually, I think that if we go to Desmos, is it desmos.net? No. Desmos. There we go, desmos.com. If we go to Desmos, all right, I'll be honest with you, I'm not getting close to as far as I want to get, and I don't know if I can spend this much time on this topic, but I don't mind doing a little bit of it. Minus 2.25x plus 4.5. All right, here's my graph. And then what I'm venturing to say is that this probably looks something like x plus 3, x minus 2, x minus 3. All right, it looks something like that. The problem is I'm going to put an a out in front, and what I want to do is probably make the a smaller, like let's try 0.4, 3, 0.2, 0.25. Aha! Because what that a does is it stretches, or makes my graph look a little bit better. Hey, guess what? I figured out a way to factor this equation down. Done. Does that sound good to you? All right. So I'm going to show you folks one more thing really quickly as to what we do in Func 7. And then I need to move on to Func, the other one. Let's see. I want to fit. Okay. So what we do is, what if we had two functions equal to each other? Like, let's look at something really terrible. Like, how's about this one right here? 2x cubed minus x equals x cubed minus 3x squared plus 3. Really, what I kind of want you to think of this as, see this one, I'm going to call f of x is equal to 2x cubed minus x. And I'm going to call g of x equal to x cubed minus 3x squared plus 3. I'm going to call f of x be the one on the left, and I'm going to call g of x being the one on the right. And really what I'm asking for is, what is f of x, or when does f of x equal to g of x? Are we cool with that? That's what I'm asking you to find. What I'm proposing is, I'm going to say this. What I do is, if I'm setting them equal to each other, why don't I do this? Is that cheating to anybody? Is anyone freaked out about what I just did? F of x minus g of x equals to 0. All I did was I subtracted g of x from both sides. That shouldn't really freak you out. And we can say that this is some new function, f of x minus g of x. That's some new function. We can even call it h of x if we want. I don't think I will, but I mean, I'm just saying we could if we wanted to. Equals 0. Essentially, all I'm doing is I'm asking you to find the zeros of this new function, f of x minus g of x, that's on the left-hand side. Are we cool with that? So, what I'm going to do is I'm going to take my original equation. Here's my f of x. And I'm going to set it equal to g of x. And then I'm going to move everything over to the left-hand side. 2x cubed minus x cubed plus 3x squared minus 3 equals 0. Will I give it the same answer? Yes, it gives me the same answer because I didn't do anything mathematically crazy to it. Okay. Let's see what just happened. Oh, here we go. All right. All right. And then what I'm going to do is I'm going to simplify this a little bit better. This will be x cubed plus 3x squared minus x minus 3 equals 0. All I did was I combined like terms. And the only thing that was alike in this game was this guy and this guy. Everything else was different, so I just kind of combined all the stuff that are alike. And then look, they gave me the graphs for a few of these things. And one of the graphs they gave me was this guy right here. X cubed plus 3x squared minus x minus 3. And what was I trying to do? I was trying to find the zeros. And you can see over here that the zeros are negative 3, negative 1, and 1. Zeros at x equals negative 3, negative 1, and 1. So what are your answers? Negative 3, negative 1, and 1. That's it. Bada bing, bada boom. You're all done. Hey, I don't know why I've got into my Italian voice. Do I literally only have 10 minutes to cover 7.3 because everything else was review? Gosh. And here's the problem. We can't slow down much, can we? Because this is math class. I almost feel like maybe it was a mistake that I covered. I didn't finish 7.3. I'll tell you what I'd do. I apologize for class going so fast. I mean, we just got to get through this material. I'll tell you what I got to do is tomorrow I have to record a lecture on 7.3, 7.4. I will post it up to class along with this archive as well. Today, I guess, was more of a review day for you folks. And tomorrow I'm going to have to get into, I'm going to have to cover like what I was supposed to cover. And I'll tell you what, yeah, you can attend the class. Why don't we make it from, we'll go early, like 8 to 9 or something like that. Tomorrow morning. Does that work for you guys? That's before any of the other classes. I'm going to cover an optional class from 8 to 9. You guys can come in early and hang out with me, and I'm going to cover 7.3 and 7.4 in great detail. But for now, I'd like to go through a little bit of it, and then I'll go into it in great detail, and I want you guys to watch that, and that will cover for my lecture. And today, what I did was I kind of let you guys, I backed off, and I didn't cover what I was supposed to cover. I redid function 6 homework for you, which I showed everyone how to do the right equation because a lot of you folks were having trouble with it. And I also recapped function 7.1 and 2. But you also can watch the video for function 7.1 and 0.2, and we can move on from there. Okay. Let's see. Oh, okay. Oh, this is actually really straightforward. I think that I can get through 7.3 in 10 minutes. Let's do it. All right. The next thing I'm going to ask you to do is I asked you, when does f of x equal to g of x? Well, the next thing I'm going to do is say, well, when is f of x bigger than g of x? When is this graph above the other graph? That's really what it's asking. So let's just skip the warm-up and we'll try to do this. All right, so when does negative 1 bigger than x minus 1? Well, my friends, you simply solve it. You just say, all right, fine. Negative 1 plus 1 is bigger than x. So 0 is bigger than x, or x is less than 0. That's all you do. Do they literally have harder problems? Like that was not bad at all. Here's a good one. Here's a good one. All right, let's do this one. Negative x squared plus 4 is smaller than 0. Okay, let's do this. Negative x squared is smaller than negative 4. Okay? I don't know if you learned this, but whenever you divide both sides by a negative number, when you have inequalities, did you guys learn to flip the inequality sign? Yeah, okay, all right, I was just making sure. X squared is greater than or equal to positive 4. Okay, and then I'll take the square root of both sides, so I have x is bigger than plus or minus 2. I wonder if that's... No. I don't like this. That's the wrong way to teach you. I apologize. Let me try this. I just realized that I think that my way of doing it might be a little bit, how do I say, dirty, I guess. What I'm asking you is, see this right here? Think back to our quadratic days. All right? Think back to our days when we were doing quadratic equations and graphing them, graphing parabolas. What kind of parabola is this? Upside down, happy face, sad face, which one? It's a sad face. Okay. What about the 4? What does the 4 do? It moves it up by 4 on the y-axis. Okay, good. So if I were to graph that, that's pretty simple to graph. 1, 2, 3, 4. I'm looking at something like that. We cool? And if I set that equal to 0, if I set it equal to 0, negative x squared plus 4 equals to 0, then I would get x equals plus or minus 2, and no one would be really worried about that, right? Using those similar steps that I just did above. Just changing all those things to an equal sign. So this right here is negative 2, and this right here is positive 2. And I'm talking about the x coordinate of this. Are we cool with that? So really what I'm asking for in this equation is, when does this graph, when is it below 0? That's what my question is. What x values give me the y value so that it's below 0? Well, whenever x is smaller than negative 2, or whenever x is bigger than positive 2. And you can see that from the graph. Anywhere in this section right here, and anywhere in this section right here, gives me a y value that's negative. So that's the way you would answer. In fact, I think the way I have you answer it in the computers, you would say, well, it's between negative infinity, comma, negative 2, parentheses, or 2 to infinity. It's in between those two. You see what I mean? Now the danger of the way I showed it to you is I think that I have to think of something a little bit, there's something funky happens with this step that I did right here, between here and here. And I need to think about it a little bit more, why we can't just do it analytically as opposed to doing it algebraically or doing it graphically. But the answer that I got over here is a little bit different from the answer we got over here. Okay? So anyway, that's why I said, I think that what I showed you was a little funky. It was wrong. But I mean, using this graph, we can easily answer part B. When is this thing bigger than 0? Well, it's between negative 2 and positive 2. That's when the y value is bigger than 0. When is it bigger than 3? Well, it's between negative 1 and positive 1. Done. When is it smaller than negative 1? Well, when is it smaller than negative 1? Well, we got to figure out what that answer is. looks like 2.14 or something like that. So it's between negative infinity and negative 2.14 and positive 2.14 and above. And we'll get into that. Why don't we cover that tomorrow morning at 9 o'clock? All right, I got to start chemistry class. Sorry that I have to go so quick. Or 8 o'clock. Yes, I'm sorry, 8 o'clock. 8 to 9. Okay.